Hello and welcome, dear learners, once again to Mathlete Minds. We continue our journey of coordinate geometry. This is the second video on coordinate geometry, completely based on Class 10 CBSE syllabus. Now, in the previous video, we had discussed about distance formula and some very simple applications of the distance formula. We continue with distance formula, and in this particular video, we'll check upon more of these numericals based on distance formula. To begin with, the first one that we have over here is find the angle subtended at the origin by the line segment whose endpoints are 0, 10 and 10, 0. Find the distance between them. Now, when you look at the points over here, 0, 10 obviously will lie on the y-axis and 10, 0 will lie on the x-axis. So, the angle subtended at the origin over here is 90 degrees. So, the angle that we get over here is 90 degrees. Distance between them, that is AB, we can easily calculate using the distance formula. So, we get here 0 minus 10 the whole square plus 10 minus 0 the whole square, that is equal to 100 plus 100 under root, that is equal to root 200, that is equal to 10 root 2. So the distance between the 2 points is 10 root 2 units. The next question is, if the point P, k minus 1 comma 2 is equidistant from the point A, 3 comma k and B, k comma 5, find the values of k. So here we are given that the point P is equidistant from these 2 points. That means PA is equal to PB. This is just a representative figure over here. We are not doing the exact figure over here every time. You can just draw a representation of the figure so that there is more clarity in solving. Now PA is equal to PB. This implies that PA square is equal to PB square. So let us see what is PA square. PA square will be given by k minus 1 minus 3 the whole square plus PB this will be 2 minus k the whole square. And PB square will be given by k minus 1 minus k the whole square plus 2 minus 5 the whole square. So this becomes equal to k minus 4 the whole square plus 2 minus k the whole square is equal to minus 1 the whole square plus minus 3 the whole square. So on further simplification, this will give us k squared minus 8k plus 16 plus 4 plus k squared minus 4k is equal to 1 plus 9. So this becomes 2k squared minus 12k, and this is 16 plus 4 is 20 and this is 10. So plus 10 is equal to 0. So this becomes, take out 2 common, so we are left with k squared minus 6k plus 5 is equal to 0. Factorizing this using the middle term splitting, k squared minus 5k minus k plus 5 is 0. So this becomes k minus 5 minus 1, k minus 5 is 0. So the two factors are k minus 5 and k minus 1. So equating each one to 0, we get k as equal to 5 and 1. So these are the values of k, and both the values are possible. You can substitute here and check out the distance PA and PB will come the same. Find the distance between the pair of points A sin alpha, comma minus B cos alpha and minus A cos alpha, comma B sin alpha. So here the distance AB between the 2 points, if we take this as x1, y1 and this B as x2, y2, we will get here AB will be equal to A sin alpha minus A cos alpha whole square plus minus B cos alpha minus B sin alpha the whole square under the radical sign. So this becomes equal to A sin alpha plus A cos alpha, take out minus common, whole square. From here also minus common and square of minus is plus. So this becomes B cos alpha plus B sin alpha the whole square inside the radical sign. Now from here we can take out a square common sine alpha plus cos alpha the whole square. From here we can take out b square common cos alpha plus sine alpha the whole square inside the radical sign. From both the terms we get sine alpha plus cos alpha the whole square common, and we are left with a square plus b square inside this radical sign. So we can take out sine alpha plus cos alpha common, and inside the radical sign we are left only with a square plus b square. So the distance between the 2 points is given by this particular expression over here. The next question is, show that the points minus 3, 2, 4, 4, 2, minus 3 and minus 5, minus 5 are the vertices of a rhombus. Also find the area of the rhombus. So here I would like to remind whatever figure is given. Here we are given rhombus. So in a rhombus we have to get back to the properties of these figures. Now in a rhombus we know all the four sides are equal and diagonals are unequal. Similarly, in the case of a square, all the four sides are equal, diagonals are also equal. If we get a parallelogram, opposite sides are equal, diagonals are unequal. So you need to get back to the properties accordingly and then show your proof. Now here, let us find out, because it is a rhombus, we will find the distances between all the sides. So AB will be equal to minus 3 minus 4 the whole square plus 2 minus 4 the whole square under root. So this becomes root 49 plus 4, that is root 53. Similarly, BC will become equal to 4 minus 2 the whole square plus 4 plus 3 the whole square under root, that is 4 plus 49, that is equal to root 53. Then CD, that will be equal to 2 plus 5 the whole square plus minus 3 plus 5 the whole square, that is equal to 49 plus 4 under root, that is equal to root 53. Then dA, that will be equal to minus 5 plus 3 the whole square plus minus 5 minus 2 the whole square under root. So this becomes 4 plus 49 under root, that is root 53. So all the four sides are equal. So possibility is it can also be a square. Now we need to show that the diagonals are unequal. So AC, let's calculate AC. AC will be minus 3 minus 2 the whole square plus 2 plus 3 the whole square under root, that is equal to 25 plus 25, that is root 50, that is equal to 5 root 2. Then BD. BD is equal to 4 plus 5 the whole square plus 4 plus 5 the whole square under root, that is 81 plus 81, that is root 162, that is 9 root 2. So now we know that the area of a rhombus, first of all let's check this, AC and BD are unequal, so definitely it's a rhombus. Now area of the rhombus is given by half the diagonals, product of the diagonals, half D1, D2. D1 is AC, D2 is BD. So we get here half into 5 root 2 into 9 root 2. Root 2 and this gets cancelled, so we are left with 45 square units. So the area of the rhombus is 45 square units. The next question is, two opposite vertices of the square are minus 1, 2 and 3, 2. Find the coordinates of the other two vertices. Now here this particular question is significantly important. First of all, you notice over here in this question you are getting the y coordinates the same. So there are two ways of solving it. You can either do it logically when the y coordinates are same, or with a little bit of reasoning by drawing the particular figure on the coordinate plane and then getting the values of b and d, the other two coordinates. Otherwise, you can take up the help of another formula. We'll be discussing both the methods. So first, let us take the simpler option. This is minus 1, 2. So I have marked it in the required place on the coordinate plane. This is 3, 2. Now we know that the diagonals in a square are equal. So obviously this distance AC is equal to BD. Now AC, the distance over here is equal to 4 units, minus 1 this side plus 3 here. So that becomes the distance is 4 units. So BD will also be 4 units. Now, this distance, of course, the diagonals bisect each other. So this is 2 units, this is 2 units. So definitely when we draw this BD over here, which has got this distance has to be 2 units from here. BD comes on this line over here. And we can easily draw BD. This is 2 units, this is 2 units. So D, like if you take 2 units over here, this falls over here on the x-axis and this falls on the y-axis. Now if you look at D carefully, D has the x-coordinate 1 unit, and similarly here for B also the x-coordinate will be 1 unit. And D, since it lies on the x-coordinate, the value of D will be 1, 0 coordinate, and this will be 1, 4. Why 4? Because the height of this B over here is 4 units. So we get these values by systematically checking out the figure, and this is especially possible when you get the y coordinates the same and you draw the figure accurately. But supposing the diagonals are not lying in the horizontal way or in the vertical way, and they are in a diagonal or oblique manner, in that case, to solve this question, we can take the help of the other method that is there. We know that the sides are all equal. So supposing I take the coordinates of B as x comma y. We don't know the coordinates, now I found it out. So let us take the coordinates of B as x comma y. So we'll write down AB is equal to BC. We know the sides are equal. So AB square will be equal to BC square. So if we take AB square will become minus 1 minus x the whole square plus 2 minus y the whole square. And BC square will become x minus 3 the whole square plus y minus 2 the whole square. Now 2 minus y the whole square and y minus 2 the whole square are the same. So we can eliminate this and we are left over here with x square plus 2x plus 1 is equal to x square minus 6x plus 9. So x square gets cancelled. You are getting 8x is equal to a. That means x is equal to 1 unit. Now we get the value of x. Now to calculate y, we'll take the Pythagoras theorem. AB square plus BC square is equal to AC square. AB square we know that is equal to minus 1 minus x the whole square plus 2 minus y the whole square. BC square is x minus 3 the whole square plus y minus 2 the whole square. AC square, that will be minus 1 minus 3 the whole square plus 2 minus 2 the whole square. Now if you simplify this, we'll get here minus 1, or we can make it plus 1 plus x the whole square plus 2 times 2 minus y the whole square. These two mean the same thing, so we can take it as 2 times 2 minus y the whole square plus x minus 3 the whole square is equal to 4 the whole square, that is 16 plus 0. So in order to continue with this, we have here the expression x plus 1 the whole square. So x plus 1 the whole square plus, we are getting here the next term, x minus 3 whole square plus 2 into 2 minus y the whole square plus 2 into 2 minus y the whole square plus x minus 3 the whole square is equal to 16. So now simplifying this further, we get here x square plus 2x plus 1 plus this will be 2 into 4 plus y square minus 4y plus x square minus 6x plus 9 is equal to 16. So we get here 2x square minus 4x, 2x square minus 4x. And this is 1 plus 9, that is 10. So we get here 10. This you open up the bracket, this is 8 plus 2y square minus 8y, and Now this we have already simplified, so this is equal to 60. Now putting the value of this x is 1. So 2 into 1, the whole square minus 4 into 1 plus 10 plus 8 plus 2y squared minus 8y minus 16 is 0. 18 minus 16, that is 2. So we get here 2 minus 4 and again plus 2. 10 plus 8, 18 minus 16, that is plus 2 plus 2y squared minus 8y is 0. So this gets cancelled. So we are left with 2y squared minus 8y is 0. Take out 2y common. So y minus 4 is equal to 0. So y is either 0 or y is equal to 4. So this is what we were getting earlier also. And so this method can also be applied. Next question is, if Pxy is a point equidistant from the points 6, minus 1 and 2, 3, then show that x minus y is equal to 3. So it is equidistant. That means PA is equal to PB, which implies PA square is equal to PB square. So what is? Let us take the coordinates of P. Coordinates of P are given as xy. So we get here x minus 6 the whole square plus y plus 1 the whole square is equal to x minus 2 the whole square plus y minus 3 the whole square. So this becomes x squared minus 12x plus 36 plus y squared plus 2y plus 1 is equal to x squared minus 4x plus 4 plus y squared minus 6y plus 9. So x squared, y squared, first of all, let us eliminate this. Minus 12x minus 4x. That will give us minus 8x. Plus 2y minus 6y. This comes this side and we get here plus 8y. 36 plus 1 is 37. 37 minus 13. That will give us plus 24. That is 0. So take out minus 8 common. So x minus y, x minus y minus 3 is equal to 0. So this means x minus y minus 3 is equal to 0, and this is what we have to prove. I hope it is clear. So everywhere we are following the distance formula with a slight difference in the approach. The next question is, find the coordinates of the circumcenter of a triangle whose vertices are 3, 0, minus 1, minus 6, 4, minus 1. Also find its circumradius. So circumcenter of the triangle is the particular point which is equidistant from the the particular circle that has been drawn touching or passing through the vertices of the triangle. So if this P is the circumcenter over here, PA is equal to PB is equal to PC. Let us take the coordinates of P as x, y. So because we have here all these like A, B and C will be equidistant from the point P. So we get here PA is equal to PB is equal to PC. Now there are two variables that we have to find. So we'll frame two equations and solve it. So let us see what can be done. If I take PA squared is equal to PC. Purposely I'm taking PC because there is one coordinate 0. So keep in mind all these things, so work becomes a bit easier. Definitely you can take PB also, but I have taken PC. Now PA square will be equal to x minus 4 the whole square plus y plus 1 the whole square is equal to x minus 3 the whole square plus y minus 0 the whole square. So this becomes x squared minus 8x plus 16 plus y squared plus 2y plus 1 is equal to x squared minus 6x plus 9 plus y squared. So x squared, y squared get cancelled. Minus 8x plus 6x, that will give us minus 2x. 2y plus 2y. 16 plus 1 is 17. And 17 minus this is 9 over here. So we get over here plus 17 minus 9, that is equal to 7. Sorry, 8. We can take out 2 minus 2 common, so we are left with x minus y minus 4 is equal to 0, equation number 1. X minus y minus 4 is equal to 0. Now I'll take PB and PC. So PB is equal to PC. PB is equal to PC. That means PB square is equal to PC square. So let's get back to the coordinates of PB and P and C. PB will be x plus 1 the whole square plus y plus 6 the whole square. X plus 1 the whole square plus y plus 6 the whole square, that is equal to, this will PB square. And PC square will be x minus 3 the whole square, x minus 3 the whole square plus y minus 0 the whole square. So this becomes x square plus 2x plus 1 plus y square plus 12y plus 36 is equal to x squared minus 6x plus 9 plus y squared. So y square, x squared, they get cancelled. 2x and this is minus 6x, so this becomes 8x. Then plus 12y, and this is 37, 37 minus 9 again. So 37 minus 9, that is equal to 28. Sorry, 37 minus 9, that will give us, yes, 28. That is equal to 0. So we can take out 4 common from here, and this will give us 2x plus 3y plus 7 is equal to 0. So I'm just checking out the signs, 12y. So this is, yes, plus, and this is minus, this also becomes plus. So we get another equation over here, equation number 2. Getting back to the first equation was x minus y minus 4 is 0. So x minus y minus 4 is equal to 0. Now let's solve these two equations. By any method you can choose to solve. I'm multiplying the first equation by 2 and rewriting the second as it is. 2x plus 3y plus 7 is 0, and 2x minus 2y minus 8 is 0. So on subtraction, this gets cancelled. This becomes 5y is plus 15 is 0. So y is equal to minus 3. So we get y as minus 3. Now put the value of y in the first equation. X minus y minus 4 is 0. So this becomes x is equal to y minus y plus 4. Take it to the right side. So y is minus 3 plus 4. So this becomes 1. So x is equal to 1. So that's all in this particular video. Hope you liked the explanation. Kindly like, share and subscribe to the channel. You can add up your comments. So thank you for watching once again.